Welcome to the Advanced Drug Dosage Calculations Workshop presented by Germanna Community College Tutoring Services. Today we're going to discuss pediatric calculations. That will include how to calculate a BSA, how to convert adult dosages to child dosages, and also how to check safe dose ranges. We will then discuss IV flow rates in both milliliters per hour and drops per minute. Then we will talk about heparin and IV calculations using both milliliters per hour as well as units per hour.
Let's look at some pediatric dosages. Remember that children are smaller than adults, so we have to round their dosages to the hundredths place in order to get a more accurate reading. A lot of times we're going to have to calculate the child's BSA so that we can calculate the required dosage ordered for that child. We also want to make sure we can check safe dosages as labeled on the drug itself or in the drug resource manual. This just isn't for kids, but also for any sensitive medications or critical care patients you have. First, let's look at finding dosages based on weight. Let's say a physician orders a medication at 10 milligrams per kilogram for a child weighing 30 kilograms. We need to know how many milligrams we're going to administer to our patient. First, we want to pull out our information. We can see we're supposed to give 10 milligrams to 1 kilogram. Our patient weighs 30 kilograms. We're going to have to convert that 30 kilograms into milligrams by whatever method we choose to use. In this case, we're showing the ratio method. It doesn't matter which method you use, we'll discover we need to give 300 milligrams. Now, like I said earlier, sometimes we might have to calculate a BSA for a child. BSA stands for Body Surface Area. It's calculated in meters squared. We can find BSAs using either pounds and inches or kilograms and centimeters, depending on what units we're given. BSA is equal to the square root of pounds times inches divided by 3131, or the square root of kilograms times centimeters divided by 3600. You must memorize these equations. One trick to help you remember which number goes with which unit: pounds and inches, they have an L and an I. They kind of look like ones, so that way we know the 3131 stays with the pounds and inches, and the 3600 goes with the kilograms and centimeters. Let's say we want to find the BSA of a child who weighs 36 pounds and is 30 inches tall. Well, first we can see we're given our weight in pounds and our height in inches. Therefore, we want to use the correct equation of 36 pounds times 30 inches divided by 3131. We're going to multiply the 36 times the 31st, then divide by 3131. Do not clear your calculator and do not round it. We want to immediately take the square root of that number, and it gives us 0.587. We always round our BSAs to the hundredths place, so we're going to round this to 0.59 meters squared. Now sometimes we're going to have to find a child's dosage based on an adult dosage given. We can do this by using a formula. That formula is the child's dosage is equal to the child's BSA divided by 1.7 meters squared. We divide by the 1.7 meters squared because that's the average adult BSA. We then will multiply by the adult dosage, and we should end up with the equivalent child's dosage. For example, let's say we have a child with a BSA of 1.3 meters squared. The doctors prescribe a medication with the normal adult dosage of 100 milligrams. They want to know how much medication we're going to give the child. Well, we're going to use that formula. We're going to take the child's BSA of 1.3 meters squared, divide it by the average adult BSA of 1.7 meters squared, and then multiply by the adult dosage of 100 milligrams. In doing so, we get 76.47 milligrams. We round this to the hundredths place because it's a child's dosage. Now let's look at finding safe dosages. We always want to be aware of how to check these. That way, whatever patient we have, we can calculate the safe range for that medication and for that patient and make sure no medical errors were made, whether it was the doctor writing it down or maybe we looked at it wrong. Whatever the case may be, we want to make sure the medication we're giving the patient is truly safe to give them. Safe dosages may be written as a specific amount of milligrams per kilogram per day, or even milligrams per meter squared per day. It just depends on if they're basing it on weight or body surface area. Sometimes the safe dosage is going to be given as a range, such as 10 milligrams to 20 milligrams per kilogram per day. If that's the case, we're going to have to figure out the very minimum we're allowed to give our patient and the very maximum we're allowed to give our patient, and then take the doctor's order and compare it to that amount. We want to make sure the doctor's order falls right in between the minimum and maximum. We don't want to give too little under the minimum, and we don't want to give too much over the maximum, as it could be harmful to our patient. So let's say the doctor prescribes chloral hydrate 75 milligrams by mouth to sedate a 3 kilogram child. We look it up in the drug resource manual, and we see it states that the recommended dosage is 25 milligrams per kilogram per dose, and we want to make sure the ordered dosage is safe. So in order to find the recommended dosage for the child, we know we're allowed to give 25 milligrams per kilogram per dose, and we know how much our child weighs. So we should be able to figure out the recommended dosage. After we find out the recommended dosage, we then can pull out the doctor's order and make a comparison. So first, let's find the safe dosage for this child. As it told us in the problem, we're allowed to give 25 milligrams per kilogram per day. Our child weighs 3 kilograms, so let's convert that to milligrams in order to discover the safe dosage. You can use any of the 4 methods you used, such as the ratio method, and we will discover that our ordered safe dosage is 75 milligrams per dose. We can compare that to the prescribed dosage of 75 milligrams per dose, and we can say, sure, they're exactly the same, so the order absolutely is safe to give. Now let's say we have a safe dosage that's given as a range. The doctor prescribes chloral hydrate 75 milligrams by mouth to sedate a 3 kilogram child. This time the drug resource states that the recommended dosage is 20 to 30 milligrams per kilogram per dose. We want to know if the dosage is safe. Well, we're first going to have to find the recommended dosage for the child, and then we'll compare it to the prescribed dosage. In order to find the safe dosage, we're first going to have to calculate a minimum dose. It told us we're allowed to give 20 milligrams per kilogram as a minimum. We have a 3 kilogram patient, so we're going to set up our problem. One of the 4 methods will work. In this case, we're looking at the ratio method. And we discover we're allowed to give a minimum of 60 milligrams. We then will do the same with the maximum dosage. We know we're allotted to give 30 milligrams per kilogram as a maximum. We need to convert our 3 kilograms into milligrams. We can set this up using any of the methods we learned. In this case, we're using the rainbow method. And we'll discover we can give a maximum of 90 milligrams. We then are going to have to compare what the doctor ordered to our safe range. As we can see, our safe range is 60 to 90 milligrams per dose, and the doctor ordered 75 milligrams. The 75 falls right in between the 60 and 90, so therefore the order is going to be safe to give. Now let's talk about IV flow rates. Flow rates can be calculated in 2 ways. Milliliters per hour, when we take the volume in milliliters and divide by the time in hours, or drops per minute, where we take the volume in milliliters, divide by the time in minutes, and then multiply by a drop factor. In either case, all IV calculations have to be rounded to a whole number. Now we want to see, how do we know when we're using milliliters per hour? Well, anytime we have an electronic infusion device, we should know we need to set the IV rate at milliliters per hour. And again, this has to be rounded to a whole number, as the machine won't let us calculate decimals. Electronic volumetric pumps infuse into the vein under pressure, and they don't need the assistance of gravity. That's why we can just set it electronically to the milliliters per hour. So anytime you see that we're using an electronic device or an electronic pump, you should know that we're using milliliters per hour for our IV rate. Let's look at an example. A patient is to receive 250 milliliters of normal saline solution over 2 hours. What's the infusion rate? Well, we know we're going to take the 250 milliliters, divide by the 2 hours, and our result is 125 milliliters per hour. Now sometimes we're going to have to use drops per minute. Anytime the electronic infusion pump isn't used, we're going to have to use a gravity pump. The gravity pumps are manually regulated in drops per minute. They're regulated through the use of a drop factor. That's the calibration of the IV tubing, and it's always measured in drops per milliliter. It literally means how many drops I'm cutting up that milliliter. There are two common types of tubing. We have macro drop tubing, and that can deliver either 10, 15, or 20 drops in a milliliter. The 10, those would be pretty big drops. 15 would be a little bit smaller, 20 would be a little bit smaller, but it's all still the same amount of liquid, 1 milliliter. We also can deliver it in micro drop tubing. That delivers 60 drops in 1 milliliter, 60 drops per ml. These are really, really tiny drops. It's the same amount of liquid, but it's cut into 60 drops this time. You need to know that a macro drop means 60 drops per milliliter. Let's look at an example. Let's say a patient is to receive potassium chloride 40 milliequivalents and 100 milliliters of normal saline over 40 minutes. The tubing set is calibrated at 60 drops per milliliter. What's the drip rate? Well, there's two clues telling us that we're finding drops per minute. First, they're giving us a tubing set with a calibration, and they're also asking us for a drip rate. Therefore, we need to take the amount of liquid related to a time in minutes. As you can see, we have 100 milliliters over 40 minutes. Then we'll multiply by the drop factor of 60 drops per milliliter, and we end up getting 150 drops per minute. Let's talk a bit about heparin. Heparin is an anticoagulant, and the dosages are measured in units. Heparin can be administered through an IV or subcutaneously. It's never administered intramuscularly. When administered subcutaneously, a syringe is used and the answers are expressed in the hundredths place. When administered through an IV, the order will either be given in units per hour or milliliters per hour. Usually the order is given in units per hour and it has to be given on an electronic infusion pump. Therefore, you're going to have to calculate the milliliters per hour. Units per hour is very similar to milliliters per hour. All it means is you take the volume in units and divide it by the time in hours. Let's look at a calculation. Let's say we have an order for 3,000 units of heparin to a liter of IV solution. We have available 2,500 units per milliliter. We need to know how many milliliters of heparin we're going to administer via the IV. Well, we can pick out from the problem that for every milliliter, there's 2,500 units. We need to give 3,000 units, but we need to convert that to milliliters in order to know how much to give. We can set up our problem in any way we like. In this case, we're using the rainbow method. And we'll discover that to give 3,000 units, we're going to have to draw out 1.2 milliliters. Heparin can also be given as an IV. Let's say our patient is receiving 20,000 units of heparin and 1,000 milliliters of D5W IV at 30 milliliters per hour. They want to know the heparin dosage he's receiving. That means they want to know the units per hour. If we look at our problem, we can see that there's 20,000 units in 1,000 milliliters. We also know our flow rate is 30 milliliters per hour. We need to convert 30 milliliters per hour to units per hour. Notice the time does not change. All we need to change is the 30 milliliters into some unknown number of units. And we can do this because we're given a relationship between units and milliliters, the 20,000 units to 1,000 milliliters. We now can set up our problem, whether we use the ratio method or dimensional analysis or even the formula method. It doesn't matter which method you use, we'll still discover we're giving 600 units every hour. Now remember, Tutoring Services has handouts that you can pick up for more practice. These are in the hallway outside both our offices at either the Locust Grove campus or the Fredericksburg area campus. How to solve drug dosage problems and also drug dosage practice problems. You can also download these from our website under Helpful Handouts. A third handout you might find interesting is test-taking strategies for nurses. This is a little booklet that kind of gives you a couple pointers on how to take tests. And don't forget, if you need more help, we always have our one-on-one tutoring. Just stop by our office or call and you can make an appointment.